Hello everybody. Today we're taking it easy to begin the year. We're gonna have some fun with shape and animations in SwiftUI. We're gonna draw a time button where some determined time will elapse, and if the user doesn't react to the button, we will trigger the action for them. We will be using shape to draw the timer around the button, and then we'll use animatable data along with SwiftUI animations to automatically trigger the action and animate the time passing. We will do this project in the animation showcase. We have done previous video here to add buttons with some colors, icons, and other effects that we have here. So for this video, what we're gonna do is another custom input. It's gonna be one of these buttons. However, it will be one of them that has a timer, where after some time passes, if the user hasn't tapped the button, we will execute automatically the action for them. So basically what we want is, if the user doesn't tap on the button, this will happen after a determined amount of time. So let's create that new view, which will have those properties. It will be a timed button. We'll have a capsule button, and we'll have a title. Let's add more space. So the timer, how we're going to express it is a border that will start coloring the edges of the button. And for that, the easiest way is to do a shape. Timed capsule, since the capsule button is also using the shape of the capsule, and it will be a shape. Now, to conform to shape, the only thing we need to do is implement the path. And let's start. So our timer will start here at the top in the center, and it will start filling clockwise. So first we've got to move the path to that point. We could use 0 as a reference for Y, but it's just best practice to use the rect that's provided. So we'll get the mid X coordinate and the mean Y coordinate instead of 0. And since this has different types of lines, so here we will have a straight line, here we have a curve, another straight line, another curve, and it will end with a straight line. We'll do this by segments. In order to draw this, our time capsule needs to have a %, so we know how much of the shape to draw, sorry. And how we will visualize this is it will be an overlay. And we'll use in our time capsule. And the % for now, let's make it 50. Yeah, sure. So we should see, if we do it right, the shape should be filled up to here, and it will be a stroke. And let's start. There will be a lot of code for drawing the different segments, so we will create functions for each of those. So let's first adding the first line to the path. We'll be mutating the path, so it will be an in-out variable, and we will be using the rect as well. Okay, first thing is how much of the % we're going to be using to fill in this line. So we'll up to 50% we will fill from the origin here towards the beginning of the arc. Then we'll have the total distance, which will be from the origin, and this is the total distance horizontally. So we'll put max x minus mid y, let me get to that in a moment, and minus the min x. So the max x minus the mid x will be up to here, and because it's a capsule, we will use the mid y, which we will treat as the radius for this arc here. So this is why we have the mid y, is minus this part of the curve and then what's left. So now that we have the total distance, we need to calculate the distance that we're going to draw. So distance, oh yeah, and first, because the percent will be 15 or more when we draw to here, so it will be like it's 1%, 2%, 3%, and if it's 15 or more, it will still stop here since we are just drawing that first line. So we need a relative percent, which will be the minimum, which is the maximum percent, and the percent. And that way we guarantee that we stop drawing the first line here. So the point from when we're going to draw the line will be in the y, it will remain in the same part that we started, so that will be the min y, the top part. And here we start from the mid x plus the total distance. Oops, sorry, it's actually the distance. We need to calculate first the distance, which is the total distance times the relative percent, and let's include the name, over the total, the max percent. And here we just do the mid x plus the distance. Now all that's left is to mutate the path, and we call the method. So we are adding that first line to the path in the red. And there we have our first line. Let's test this by making it 10%. There. Okay, perfect. Now we add the first arc. This is the first interesting part. Path in SwiftUI has add a relative arc, which is what we're going to do. So here is just a trailing arc. And let's add another 15%. So the arc will be drawn from 15% to 30%. The max percent is going to be 30. And notice that because we're calling this, we don't want to guard here each time we're adding one to check the percentage. What we're going to do is we're going to guard inside. So we also need a minimum percent. Since we only draw the arc when the percent is between 15 and 30, in the other ranges, it's up to the other methods to draw themselves. So the minimum percent will be here, and we will guard against it. The percent needs to be higher than the mean percent. Else, we will return. Once again, we need to calculate the relative percentage. And now we calculate the angle. So the angle is how much we are moving. Here, if you notice, it's going to be 180 degrees. What we're going to multiply this for is 180 times the relative percent minus the mean percent, just normalizing this here, and it's the max percent minus the minimum percent. So this times the fraction here, and that should get us where, up to how much of the angle we're going to draw. Now that we have the angle, let's add a relative arc. The center is going to be this point here where my mouse is hovering. And that's going to be just like we did, where is it? Here, which is where we were stopping with our line. The y coordinate is going to be the mid y, which is going to also be our radius. The start angle, this can get a little bit confusing. It's going to be minus 90 degrees. And why is that? Because when adding one of the arcs, the degrees start with the x positive axis. That's how it's described in the documentation, which it will be here. So this is the center plus the radius. It starts here. However, we want to start right after the line, so we go 90 degrees. Why negative? Because when we go negative, that's counterclockwise. So we start here, minus 90 degrees, and we're gonna add a positive angle, meaning this will go in a clockwise direction, which is what we want. When it's 100%, we go 180, which is exactly, it ends here at the bottom of the button. Let's do that here. And let's see how it looks. How much percentage am I using here? 15. Let's add 25. There we go. If I do 35, you should do, and yeah, stop there. If we go 50, perfect. Go again to 50 so we can work with this later. So now we need to draw from here towards the end of the capsule. So we can copy this and add some of the stuff. So we are going to go again, adding the second line. We will add from the percent will be 30 to 70. Yeah, 40% will be this part below. The total distance here will be bigger, which is the max x minus the mid y, which is the radius. However, this time it will be times 2, since we're taking into account this part of this arc and also this arc, since we're drawing from one side to the other. And the distance will be similar as in the total distance times, and we'll use this part. We're normalizing the relative percent, the max percent, and the max percent using the mean percent. And then we draw the line from the max x minus the mid y, and then minus the distance. Since the path is already point here, we just need to point them to the other point where the line is going to be drawn. And in this case, our y is the max y. And we add a line. Let's put the second line to the path. Okay, 50. Let's go to 70%. Excellent. And if we go to 80, it stops there. Perfect. Now let's add our leading arc. We're going to have a similar method here. And here things will be different. So now we are starting here, which is if we start here in the center from the positive x-axis, we need to go 90 degrees down, so that's clockwise. So we do not need the negative sign. And how we will be adding this, which is called the delta in this method, we'll be going clockwise again, so yes, it's positive. Yeah, that should be it. Add it here. And that's okay. 80 was already part of the arc. Let's add 85. Good. And let's finish drawing this. 95. We should be adding the last part of the line, so will be the third line. It's pretty similar to our method here. And there we go, 95%. Let's go with the last part. 100 should close the shape. Perfect. Now, one more thing is missing. We wanted this to be animated, right? We don't want SwiftUI to start doing this from some view model, just constantly changing the value. Instead, we're gonna leverage animatable data. And it's a good thing that shape is animatable. Notice that the autocomplete already gives me an animatable data. Right now it's empty animatable because I haven't specified anything for it. Luckily, I can use CGFloat for that. In the get of the animatable data, we're gonna return the percent. And in the set, we're gonna set the value of the percent. Now we need to change our shape so with the text. The thing, what we want to do is when we turn on the animation, we want percent to go from 0 to 100. How do we do that? In the init, we're gonna add a boolean. So it's active. If it is active, then percent will start at 1. If not, it will start at 0. So if it is active, we start at 1. If not, it will start at 0. And this is what SwiftUI will use to animate. It will know that percent will go from 0 to 1. And that's what animatable data is for. We will be able to track the animation through this. And since we already coded all of our shape to react to it, it's already ready to render itself multiple times as the percent value is changing. Now, how do we handle this in SwiftUI? How do we trigger the animation? With state. So we will do a start where if it is animating, the button will not animate until we show the button. We can change this so the system can trigger it through another view model. Let's say when something in the model changes. Here we will just do it as soon as we instantiate the button, the timer will start running. How? We will do it in onAppear with animation. And we will toggle is animated. Another thing is we want the user, the developer, sorry, to be able to control the time. See how they're animated? However, we want a time button, right? And that was too fast for the user to react. So one thing we can do is add another parameter to our button. We already have the title and the action. So let's add a time. How much time is it going to animate for? And how can we control the animation? I don't need to go to shape. SwiftUI already helps us here. How? With animation. So for now, let's use an isIn isOut. And notice that we can add duration. So we can add the time here. And because we're using iOS 17, animation was already deprecated, we need a value so the engine can detect when the animation is going to start. Luckily, we already have configured the boolean that we're going to use so we can tell when the animation is starting. And let's add a time here. Actually, let's make this more convenient. Let's make this a optional value and let's make it 4 seconds. Done. Okay, perfect. Now, one thing is missing, and it's actually we want to trigger the action automatically, right? If the user didn't press it, we want to trigger it. How do we know that? We can do that here through the animatable data. We know that percent will reach its end when it reaches 1, so we can trigger the action there. And if the new value is equal to 1, then we call unfinished. And here in the time capsule, we are going to call the action. And now, all right, this needs to be sendable. And the closure is now not only escaping, but also sendable. And we need to change this. Our capsule button is no longer going to be a capsule button, it is going to be a time. Also, since the timer will already have passed and there's nothing that makes sense in actually letting the user tap the button again, we're going to not show the button if we're showing the message. And let's change this for a time button. We also need to add the title. It will be submit order, and the action we're already providing it. And remember, the time was added by default. So here we have the timer, and at the end, boom, order submitted. Perfect. Let's test it one more time in the simulator. Okay, it's instantiated. Here we have the submit order, and done. That was all for today. Hope you had fun. I enjoy a lot drawing custom shapes in SwiftUI. It's very easy to use. Path, as long as you know your way around the angles, how to create arcs, how to create lines and draw them appropriate in the rect that's provided in the path method in the shape. It's very fun, and you can draw images, and since it's a path, it scales amazing with the size, and it adapts easily to most of the scenarios you'll place them in. Also, thanks to the fact that shapes have animatable data, it is also very easy to seamlessly integrate them with SwiftUI animations as you saw in the video. Hope you liked it. Bye.